Hi Prof, my name is Cheng Han and I'll be giving the presentation. For today's presentation, I'll be touching on two case studies, one on Meta and the other on Blusterworm buffer overflow. The data breach back in 2017 affected around 50 million Meta users and it was only discovered back in September 2018. Lots of user profile information was stolen. The bug occurred on the contact import feature and the other is the password reset mechanism. Through these features, hacker managed to gain access to sensitive details such as phone number and address. As you can see here, this innocent View As button started it all. The View As function allows users to view their profile from outside the perspective. From there, attacker was able to upload video while using this feature, and this bug led to them being able to gain access tokens. Over here, you can see a third-party application, Tinder, requesting permission from Facebook for authentication credentials. Access token was hijacked over here, available on the page. The typical authorization code flow is as follows. The user is authorized by requesting the user authorizations and redirecting back to the app with the authorization code. This code will be exchanged with a request token to call the necessary APIs. Refresh token function is also embedded to ensure long-lasting connectivity. On the screen, you can see a post request and the response will be stored into the variable in red box. This is prone to scripting vulnerabilities whereby another software component is able to hide the additional commands and steal the token. These two pictures show how the script can be injected into Facebook website during the page load process. Moving on, I will touch on the password reset vulnerability which was present in Facebook beta website. User could change a password without entering the current password, and brute force algorithm is applied here in order to guess the 6-digit code. Facebook has adopted measures to prevent stealing of token, encoded their HTML text and offered bug bounty. To prevent stealing of tokens, Facebook used three methods: detection, access control list, and protected process light. Looking at this risk model, detection is done through pen testing and code reviews. An access control list ensures that need to know principle is adhered to. Security descriptor consists of DACL and SACL. Logging is done in system access control lists to track and enforce the concept of accountability. As it is one of the security fundamentals, it ensures that username and owner name are matched. The open process token takes in the process handler the respective access right flag. However, this could cause some issues when the token owner himself is denied access to his own account. The PPL fixes this issue. To ensure non-repudiation and authenticity of the user, the PPL ensures the following files are present in the system. This way, it is impossible for hackers to steal the token. Another method is through encoding of HTML text. String builder and regular expression are used to replace HTML text, so they are not displayed in readable format. To add on, researchers around the globe has earned money from reporting the bugs they found on Facebook website. This encourages developers to not exploit their findings. Consequences of the bug include 533 million Facebook users' information being compromised. 490 million records concerning 267 million Facebook users were found in the dark web, and this jeopardized Facebook integrity. Moving on to the second case study, I'll be explaining more about how the Blusterworm affected Microsoft. It was an attack launched back in 2003 on Windows OS, and many were affected. TCP/135 was exploited by hackers. So how did the bug occur? Hackers exploited a remote procedure call on Microsoft code. The worms attempt to retrieve a file, namely msblast.exe, from the victim. The file is then executed and start to scan the system for potential targets. A backdoor is generated to allow hackers to gain access to issue remote commands. Given the extensive coverage of Microsoft on end users, this has very detrimental effects. Regarding the buffer overflow exploit, hackers make use of a registry key that causes worm to run every time the system restarts. It also ensures that the victim does not get reinfected by creating a global object named Billy. The worm will read itself from the disk through function call, which is easier than hardcoding it on the disk. A pop-up will appear and this signals to the virus that a connection has been made. Before proceeding with the attack, TCP checksum is a security mechanism for ensuring protection against transmission errors. Hackers exploited this code and was able to perform stack smashing to ensure the malicious code was executed. This is how TCP checksum is calculated. I'll be covering the process to overcome the bug through antivirus and ICF. Since the way antivirus works is that it detects, quarantine, and delete malicious code on your device, it is important to update the patch when available. ICF is also a prevention mechanism to prevent unauthorized access. This is done using either hardware or software firewalls. The consequences of the bug caused the service to crash and reboot by itself. It damaged the Windows OS and more than 100,000 users were affected. From the 2 case study, we can see that it is important to adopt strong computer security measures to ensure the security is not compromised. Thank you for your kind attention.